All right. Hey everyone, my name is Akhil and I'm joined by Dylan and Shrujit, in which we collaborated on the project called Encyclopedia of Life. This is basically a web application where we have different animals that show different prominent characteristics pulling from the back end. As far as my personal contribution to go, I was working on the database side of things with the database wrapper class, as well as adding animals.database. I was also working on the Django framework at the beginning of project 5, which we had to scrap due to other technical difficulties, which will go later in the video. I was also working with React web page development, developing the web pages for the animals as they're dynamically created. And then I was also working on project 5, 6, and 7 documentations, working on drafting, finalizing, submitting the documentation, as well as the UML diagrams in which I collaborated as we changed and added classes.
Hi, I'm Dylan. So my specific responsibilities were I also worked on, all of the different documentations for the different projects. I wrote all of the 4 main patterns, including the, the facade pattern where we work with the backend database. I wrote the API. I worked on experimenting with a whole Postgres database. I wrote a parser for the CSV. Those are just some of the things I did. Shrujit, would you like to go?
Hey guys, I'm Shrujit. For my contributions, I worked on the database and added animal information to the database, worked on the UML class diagrams, assisted with creating the project documents, and lastly was involved in planning and development of the project along the way.
Okay, so we're now going to give a demo of our project. So this is what the basic site looks like. You can click on these different links and it will show you the animals. It's a pretty simple site, but the way it works is actually somewhat complicated. So our whole project uses React. The way it works when someone first accesses this page on localhost 3000 is that it makes a call to the backend database, specifically a post request to this API, which is running on a separate port. And as you can see, when I go to that link, we get this information in kind of a JSON structure, which kind of has the information on all of the different animals. Now for this specific page, we're not using all of the information. We're only really showing the name as well as a link. So the way this works is we use the database wrapper class through which we're implementing facade, and we're calling a function here, get animal list from the home page. And then what it does is for each animal in the list, it uses the flyweight pattern where the information about each of the animals isn't actually stored in this animal link class. It's passed in from this higher level homepage class. And this animal link object returns the HTML. And now what's cool about it is each of these links corresponds to like a different route. So humpback whale goes to /species/3, and blue whale goes to /species/4. So what happens when you click on these or try to access these different routes via clicking on the links is React basically tries to render this animal view page here. And the way this works is this also will make a request to the server to get everything that's in the database. And then based on the specific ID that it reads in from the URL, it accesses the correct element in the database using the database wrapper class. And then once it has the information about the specific animal in kind of a JSON, it uses the factory pattern to create an animal object based on the ID. And this animal object contains most of the relevant attributes, including the name, description, conservation status, location, as well as an image link. It also returns the HTML that is actually shown on the page. So once we create this animal object on this page, we then just call its render method, which shows all of its attributes. Some other design patterns that we used included the singleton pattern, which we used for our CSV parser. So this was all done in kind of a unique way based on because we were doing this in JavaScript and not Java. So we basically have this singleton CSV parser class, which creates an instance of this private CSV parser. And that singular instance does all of the actual matching from the CSV file. And this is what that CSV file looks like. We originally were using a Postgres database for our project, which was served on another port using Docker. But what we learned was that it was actually really difficult to use some of the Postgres clients that we found online. And it would be somewhat easier to use a CSV, although we did have to write and debug a parser from scratch, which was somewhat difficult. One of the big issues we ran into in the project was that when we were parsing the CSV, we realized that file reading classes can't actually be used on the client side. So for instance, we had stuff where like on this home page, we were trying to parse the CSV and open the file and stuff, but that couldn't actually be done. We learned that you can only actually do that in Node, which runs on the backend, which led us to kind of adopt this whole backend API approach where it's running on another port. That was a big challenge. I think Akil could also mention some other things that we ran into along the way.
Yeah, one of the first things that we, when we started this project was during Project 5, we originally were considering a Django framework for web pages, but we soon realized that with Django, we can't really utilize any OOAD design patterns, such as the singleton, flywheel, et cetera, whatever we used in our project. And to counter that, we looked into a little bit more React framework in developing our HTML and web pages. And we discovered that using React, we could potentially use JavaScript, which allows us to use these design patterns and potentially make our website as you can see it is right now. So it was a bit of a transition from Project 5 to Project 6 and 7, in which that we completely changed our framework. And one of the upsides is that we were successfully able to do so. The second big issue that came into play was with the database. When we first started the project, we were imagining an entire animal database containing all the animals. But once we started getting down and dirty into the details, we see that that database is a little bit too big in which we can handle our server requests. So we started paring it down into mammals or different kinds of animals. But at the essentially, like Dylan was saying with the Postgres and the Docker containers, we weren't able to effectively utilize the entire databases that we found through third-party websites and apps. We tried downloading multiple databases from different kinds of websites in which we would have animal data with all different characteristics, but in any of these databases, there weren't any key information that we wanted to display in our website. So essentially what we had to do was create a CSV file, like Dylan mentioned, in which we have common name, location, endangered status, a picture of it, as well as a small description. And as you can see, that turned out really well, in which we are reading from the CSV file, using that parser and dynamically creating those web pages and displaying them to the user.
Yeah, and if we have any additional time, we can just go over our UML diagram. So as you can see, we have this whole home page here, which is calling methods like rendering the nav bar. It's using the flyweight pattern here to get the specific HTML corresponding to the link. It's also using the database wrapper class to get that whole list of animals. And then once you're actually on the page corresponding to each of the animals, as you can see, the factory pattern is used. And then what the factory is doing is it's setting all of these attributes using modifiers in this animal class. And then once all of these attributes are set, it's calling this get info function in the view page itself, which returns all of the beautiful HTML corresponding to that animal. And then the last thing in our UML diagram is the singleton pattern, where we have the single instance of this one class, and then it contains that other instance, which is its only one. That's kind of the workaround way of using singleton in JavaScript. Thank you. That covers our project.
Thank you everyone for watching.
Yeah.
Thank you.